Good afternoon, my name is Carlo Palacios and I'm going to be explaining what I did for Lab 3, which was basically changing the slope algorithm from first fit into best fit. So the first thing I'm going to show is how I implemented my call by changing these 4 files over here. And well, these are basically just the declarations: the slope amount claim, free, and free. How I incremented the amount of system calls, 341, 342, so the total amount is 343. Then I also declared them here on syscalls.h. And on the make file, I was supposed to add a folder containing my system call, but since slope is inside of then I didn't need to do that. I also opened a file with the original slope over here in order to compare what I did from first fit to best fit. So being that set, I'm gonna go into my into slope, and what I basically did is change 3 methods. I changed the methods that were specified on the instructions by the TA. So whenever that opens, okay. So as you can see, that's my name, that's my partner, class, and lab. The first thing I did was, well, obviously add linkage in order for me to be able to call my syscalls, or implement my syscalls. Then I also implemented 2 arrays, which will return the amount of bytes claimed and the amount of bytes freed in this algorithm, and index will just be a variable that will be looping through these arrays. Then let's get to the good stuff, which is not that one, slope log. So the first thing that I did with slope log is create 2 variables and 1 pointer. This will point to the best page that I have, and this will accumulate the amount of free bytes, which will be used to return the bytes on the array that I first declared. And best fit will return the amount of obviously the best fit of the current location where I'm trying to allocate whatever is it that I'm trying to allocate. Now, this loop over here, this loop is the one that I changed slightly. As you can see, it's the same as this one. The difference is that in the middle of this loop, I called my helper method, and I assigned it in current fit, which is one of the ones that I was, where is it? Here, which are other methods, other variables that I added. What this is going to do, the slope page best fit, is that first, this loop is going to iterate through the list of pages that I have. And this helper method is going to go inside of that page and return the best current fit that I have, which is something I'm going to explain now. So we're going to go into that method. And this method, I found it very similar to slope page log because the methodology that I use is the same thing as that, pretty much. So what it's going to do is, these variables are the same as the slope page log, but I added 2 more, which are a pointer to the best current fit, and this will be the best fit overall. So this is basically going to iterate to 1 to each page, and this is another page to each available space, and this is going to return the better one, the best one actually. And well, this is going to iterate until the last one, as it can be specified there. So this is the important part over here. So if the amount of available space is greater than the amount of units trying to be allocated and delta, I see delta as an offset. So if it's greater than that, and as long as delta and the best current fit is not null, and or the best available, not available, the amount of available space minus the amount of units plus delta, which was the same thing as here, is smaller than the best fit, meaning that this location is actually smaller than the previous one that we had. So if those conditions are true, then this current slope is going to be considered the best one, and whatever allocation I have over here will be considered the best fit. So now if the best fit, now if this guy is 0, means that it's a perfect fit, and I will just get out of this loop over here and return 0, meaning 0 means it was a perfect fit. If not, then I'm going to iterate this into the last slope. And now as long as I'm on the last slope and the best current slope is not null, meaning that it's not the same as the original one, then I'm going to return whatever best fit I had. Not necessarily 0, it can be 0 because I was living here, so it's going to return some positive number. If not, then it will return -1. So basically, it's either going to return 0 for a perfect fit, 1 for whatever fit I found, or -1 if no space was able to be found or allocated in the page. So that will be this value over here. Now again, if this value is 0, it's the current fit, means a perfect fit, I will break, meaning I will get out of this iteration of pages, which I will no longer need since I already found a perfect fit. Otherwise means that as long as the best fit is not -1, meaning that it's not back to the original one, and as long as the current fit is less than the best fit, it will assign the same variables to the same thing. But this is just because, again, this is iterating through pages. So this is basically saying as long as the current page is less than the current page, less than the best allocation in the current page, then it will go here. Again, this will basically mean the values inside of the page, not the pages itself, the amount of free space. And it will just continue, go on and on. Now, if this best fit is greater than 0, meaning I was able to find some space, I'm actually going to try to allocate it using the slot page log, which I also changed. And it's really similar. It's different in a sense, but really similar in another one. I want to explain what I mean by that. So in the original slot page log, we see that everything happens in the iteration of the page, basically. So on the page that I was trying to allocate, it's going to return a value if I was actually able to allocate it inside of it. Since we found the other method was only to find the space. Now, if we're trying to allocate it, all of this will happen inside of the loop. And as we can see, when we find some empty spot or a space where we can allocate it, it returns automatically. And if none of that happens, then until you go into the last loop, it's going to return null. So this is the only thing that happens at this last loop. In contrast with this is that first on the loop, we're going to go and have all these declarations in the last loop, meaning that we're going to have to iterate through all the pages and see which one gives us the best, not all the pages, all those allocations possible in the page, and see which one gives us the best possible fit. So, well, I kind of explained that already. I only have like 7 more minutes. So basically, if so if I'm on the slab slope and the best current fit is not null, meaning that we were able to allocate something from here. This is basically the same method as I had on the other method, on my helper method. So as long as there is something on best current is not as the original one, we're gonna try to allocate the data inside of this page. Now, this best delta is the same thing as the original one, as you can see. The only thing is that I changed everything into best because again, this is trying to iterate, so it's going to give me the best possible option between them. So that's that part. And basically the implementation, as you can see, is the same thing as first fit. It's going to try to allocate it. It's going to, if it's an exact fit or if it's not, it's trying to allocate the pointers or for the previous and the next one. Everything is the same, so it's going to return the best current possible fit. So it's going to return some value, or it's going to return null. But all of this is going to happen on the last loop, meaning that it was iterated through the entire list. Now, once we're there, this is the value that is going to be here on B. And, well, this will actually be the same thing as the first fit. If it's not B, then that means that it was not able to find space, so it's going to try to allocate a new page And I only added this to keep track of the amount of bytes that I'm going to be returning, or I'm sorry, claim or being freed, which are basically going to be sent through these two methods. These are actually my system calls. Really simple. It's just iterating through the 100 elements that I had on the array, and it's going to return the total amount divided by 100 because the instruction said an average. So now that I have that, I'm going to move in. I'm going to pause the video and move in into my calls. So I'm going to move in into Lab3 and see all the files that I have. So basically the tester method, it's really simple. Test is called, let's see, it's just going to open when I'm calling malloc, basically. Nothing fancy. I'm gonna display my two calls by the amount of bytes claimed and the amount of bytes free. Pretty straightforward. So I also have my make file. So I just hit make. I have some warning in there. I don't know why it says that. But as you can see, we have the best fit executable. So if I run that, that's the amount of free bytes that I have claimed. Calling the wrong one. Here we go. And it does that. Now, as you can see on my files, I also have a file called here f/slob.c, which is basically the same thing as well, it's not the same thing. This is the first fit algorithm with slob, but since the assignment asks us to compare it, then I put it over here. So the only thing to see if this works is basically copy and paste this and try to implement it again, compile the kernel and do all that. Obviously, since I'm recording this through a browser, I can't test the two at the same time, but this is basically the amount of mods claimed that I had. I've been testing it for a while and it works, so I don't think I'm forgetting anything. Well, as you can see, before I didn't have the executable. My make file worked. The test is called .h is the same thing, so not the same thing, but it's pretty much the same thing as the other ones. .h files, it's just a declaration of the system calls. Nothing fancy about that. There you go. And the reason why I'm turning this on Sunday is because I was having trouble with my kernel for some reason, and it was giving me problems about Lab1. For again, some reason it wasn't implemented because of that. So once I reinstalled the kernel and I started from scratch, I was able to implement it again. So that's pretty much it. Thank you.